Do we need another book on climate change?
Well, that's a good question, Terry. There are indeed a lot of books on climate change, and there's a lot of very good books on climate change. However, the situation's changed in the last 6 months quite dramatically. And it's changed in the following way. If we go back 12 or 24 months, the great majority of the public was convinced that there was a very real problem of dangerous global warming caused by human carbon dioxide emissions. Now, it is true that we emit carbon dioxide. It's true it's a greenhouse gas, and it's a good question to ask, are we perhaps having a dangerous effect on climate? That question was first asked in the early 1990s, mainly by the big green organisations, and a sensible thing to think about. So we did. And we're now in 2010. We're 20 years down the track. We've had several thousand scientists through the Intergovernmental Panel on Climate Change. That's the United Nations body that advises governments. We've had several thousand scientists look at this. They've spent close to $100 billion of research and related money, and they have been unable to measure the human effect. Now, that doesn't mean it isn't there. It just means it's so small that we can't yet measure it, and therefore it's very unlikely to be dangerous. So, nonetheless, the public belief was, until recently, that we should do something to prevent this unmeasurable change. What's happened in the last 6 months is a number of scientific, well, scandals is probably the right word for them, and the one some of the viewers will have heard of is called ClimateGate, whereby the group in the United Kingdom, at the University of East Anglia, that was responsible for providing the United Nations with its temperature statistics, that group basically has been shown to be providing records that are historically not accurate. Now, that's caused, because there was press commentary on that, that's caused a big swing in public opinion. So we're now at a situation where the majority of the public are deeply suspicious as to whether they have been told the truth on climate change. And my book addresses that, and it addresses it by starting with the premise climate change is a complicated thing, and it's got various sides to it. You often hear it said there's two sides to the issue. Well, that's silly. There's as many sides to the argument as there are qualified scientists to discuss it. It's immensely complicated. It cannot be reduced to a he says, she says simplification. There are three lenses, if you like, through which you can look at climate change. And I call them three realities of climate change. And those are science reality, virtual reality, which is the computer modelling, and political social reality, because we live in a society, and it is at the moment true that climate change is a big political issue. It's really very important to tease out those three different realities, and that's what my book does. And then at the end of all that, having understood better the realities of climate change, it's also very important to have a constructive way forward. And so the way in which this book differs from most others on the market is it provides an explanation of what's been going on. It explains the science in an elementary way to some degree, but it provides a sensible path for future policy.
On the question of science, as a layperson, to me there's something missing from your three realities, and that is observation. Have we learned anything from history?
Well, of course, that's part of scientific reality. And the science reality is that temperature always changes, climate always changes. That's what climate does. Geologists have a long history of studying this. It's well known that just 20,000 years ago we were in an ice age, and now we're in a warm interglacial period, and in another 100,000 years in the future we'll be back in an ice age again. That's a bit longer than the next election, but those natural cycles are behind everything that goes on out the window with weather and climate. Over the longer term, over decades, centuries, millennia, and out to hundreds of thousands and millions of years, climate always changes. So you're absolutely right when you say we need to describe that and look at it. And when you do that, you say, well, here's the record of climate change for the last million years or so. What do we see? Well, we see that it always changes. But weren't we told that at the end of the 20th century we had global warming and it was dangerous? And wasn't that warming warmer than ever before, or took place at a faster rate than ever before? And the answer is no. The warming at the end of the late 20th century was a very mild warming. It falls completely within the bounds of previous natural variation. Right at the moment, we've been cooling for about 10 years, so we've turned over a little peak on the temperature curve. This is entirely to be expected, nothing to be worried about here at all, but that's part of the science reality that is missing from the public discussion.
What, again, as a layperson, what part does the sun play in influencing the temperatures on Earth?
A great deal, and it provides, I mean, there is heat comes from the inside of the Earth because, as you're aware, we have a partly molten core, and that heat is conducted outwards very slowly. So there is some leakage of heat from the inside, and a volcano, such as is erupting in Iceland at the moment, is a good manifestation of that. But the amount of heat that reaches us that way is very small compared with the amount we receive every day from the sun. So the Earth's climate system is dominantly driven by that solar radiation. Indeed, climate is basically about the redirection of that radiation around the planet. And we have convection currents which cause clouds in the atmosphere, and they go off and they cause rain and cooling. We have big ocean currents which transport heat around, and all those dynamic things that are part of climate are ceaselessly changing. But the energy that drives that whole system comes from the sun, yes. Well, the next question is then, is that solar radiation constant? And the answer to that is, well, scientists used to think so. Indeed, they used to call the amount of radiation received at the top of the atmosphere was called the solar constant because it was believed to be constant. Well, it turns out it isn't. It varies slightly on the 11-year length of the sunspot cycle, and then there are longer-term cycles of solar origin of a bit more energy or a bit less energy over periods of hundreds of years and indeed thousands of years. So the sun's energy is not absolutely constant, and our climate system reacts to those changes.
I understand from my reading that there was a solar cycle, I think it's 23, which was due to end 3 or 4 years ago, and it hasn't happened yet.
It has just happened, but it's certainly true that cycle 23 then should go through a low period. The cycles, the peak of the cycles are the many sunspots. So we have a big peak on the curve of sunspots. And then we go into a low and we come up to the next cycle peak of sunspots. And you're right, in the early part of this century, we've been on peak 23 and now coming down off it. And we're going into 24. The gap between cycle 23 and 24 turned out to be longer than usual. And when that happens, we know from the historical record of sunspot observations that the next cycle will be less intense. There'll be fewer sunspots. And that means the next cycle is also cooler. There is a planetary cooling. So because the gap or the saddle between cycle 23, which has just finished, and cycle 24, which has just started, was longer, scientists are now fairly confident that we are going to go through a couple of decades of cooler weather. How much cooler? Perhaps half a degree, perhaps a degree.
But hang on a minute. The models that we hear about from the UN IPCC and others didn't say that we were going to be cooling now. They had us warming.
Indeed. But remember, there are 3 realities of climate change. Now, we've been talking about the science reality. You're now moving on to the virtual reality. And the virtual reality of climate change is what happens inside those computer models. And essentially, they're big PlayStation 4 computer game consoles. And you put the numbers in, and you have a model of the climate system mathematically inside the black box, and out the other end comes the projected, not predicted, projected temperature in 10, 20, 50, 100 years' time. Now, why do I draw the difference between predictions and projections? And that's not my distinction, that's the Intergovernmental Panel's distinction. The difference is this, that a forecast, such as the weather forecast on the television news every night, or a prediction, has been validated. The model that produces that has been validated and shown to be accurate to a certain specified statistical degree of accuracy. The computer models used by the IPCC have never been validated. It's unlikely they can be validated. Therefore, they do not give you a prediction of what the world will be like. They give you a projection of what it might be like. But that might is one might chosen out of literally billions of alternative mights, which could equally well be the case. So the computer models, and the public does not understand this, do not predict future climate. What they do is they project a possible future climate. And because people are so concerned about global warming, including lots of the people that do the models, it is no surprise that lots of the models are organised in such a way that they project future warming.
But surely our political leaders should have picked up on this. They're supposed to be intelligent people.
Well, I'm sure they're very intelligent, Terry, but I'm not sure they should be expected to pick up. I mean, after all, every year they ask the Treasury to model the economy for the next year, and the Treasury duly does so, and the Treasury uses it in the budget. And then every year the numbers which actually eventuate are completely different to the ones that were projected, not predicted, by the Treasury. It is the nature of computer modelling that it's a game-playing exercise. It's to understand things. It's not about making predictions. You can't predict the budget exactly. You can't predict climate exactly.
But here we are in New Zealand, just 10 weeks away from having a new tax or virtual tax put on us because of these models.
Well, I have in public in New Zealand and Australia many times asked the question, how many degrees of cooling are we going to get for the amount of carbon dioxide that is not going to be emitted because of this extra tax? And I have yet to have a politician answer that question. The answer is, in fact, in thousandths of a degree. It will be unmeasurable. New Zealand could stop its entire industrial economy and transport economy tomorrow, could cut all carbon dioxide emissions. The effect on climate would be unmeasurable.
Now, you mentioned the third reality, socio-political reality. What do you mean by that?
Well, of course, that's where I start getting uncomfortable and shifting in the chair, because I'm a scientist and it's not my business to tell people about the socio-political situation. But the reality is that climate change, or more strictly global warming, ceased to be a scientific issue at least 10 years ago and has now become a political issue of the highest order. And when you look at the way the politics of that is being handled, it's a complex issue, but the big green non-governmental organisations are part of it on the world scale. And in individual countries such as New Zealand, the green political parties are part of it. And people's fears have been aroused to the point that all major political parties, be they nominally left-wing or nominally right-wing, are forced, or have been forced by public opinion, to acknowledge this threat. So the socio-political reality is that if you look at the science, as I said earlier, the scientific reality, and it says there's no danger of out-of-control global warming at the moment. If anything, there's a danger of cooling. It's not easy for a politician to get up and even say that, because they will be buried in criticism. And that's the socio-political reality, that it's very difficult for governments to handle, because you can't actually have an intelligent discussion about the science without getting enveloped with the politics of the special interest groups.
All we have is the temperature change. We don't have a smart thermometer that tells us why the temperature changed. And so we are left to argue about why the temperature changes. And you can come up with all kinds of reasons. Some of them are very plausible. But in the end, it must be verified through a modeling and predictive exercise that has yet to occur. Mm-hmm. There's a confusion in climate science that unfortunately has really caused problems with the public, is the notion of climate change. The climate always changes. It will never, ever be the same. It's a system that is never in balance, so it always changes. But it has been sort of co-opted by the current views of some people to think anytime you say climate change, you're talking about human-induced climate change. And there you get down to the why of climate change, and we don't know why. If we did know why, we could predict what is happening. We can't predict what is happening very well at all. Unfortunately, in climate science, we can't prove the why of changes that are here. We just don't have the ability to prove it. All climate scientists don't think the same thing, for sure. In fact, the American Meteorological Society only had 52% of its members agreeing with the statement over 50% of the warming in the past 50 years is due to humans. It was only 52%. So we don't even have a consensus in our own society on this. Right. Our science is just murky. We've got a long way to go in terms of this proof stuff, and I don't know if you can ever prove a particular thing right or wrong. It's just very murky. And there won't be a Nobel Prize in it because there is no Nobel Prize in atmospheric science. That's physics, medicine, economics, things like that.
Right.
There is a strong element of non-objective information going out there to convince people of one way or another about this climate issue.
Right. And do you feel like the real scientists are still a significant part of that debate, or are they being drowned out by non-scientists who have an agenda one way or the other?
You know, that's a question you might be able to answer better than me. When you say real scientists, I don't know exactly who those are anymore.
Right.
Some of them are very public advocates
Mm-hmm.
of their view. Some are pretty quiet about it, and we never hear too much about their results and their caution. Really, most of those are pretty cautious kind of people. It has been taken over really by the political world, and that's where things are being done. Just witness, you know, our Secretary of State or Vice President saying, if you don't believe climate change the way I do, you don't believe in gravity. That was said just 3 weeks ago.
Really?
And so I evidently don't believe in gravity, if you follow that logic. So there is some bullying, obviously, going on from this particular administration. And as someone who was on the list of 7 scientists to be investigated by Congress because I testified with information counter to the administration's view on climate change, I know about that political pressure. I know that they're trying to silence critics of their view of climate. We are looking at a climate system that is so complicated, we can come to different views. It is so complicated with so much information that is only obliquely apparent to us as to how the climate system might work. So having different views is hopefully the way science progresses. And the one that wins is the one that is backed up by the most evidence. And as someone who is a working stiff climate scientist, I'm one of the few people in the world who actually build these climate data sets from scratch. The evidence just does not support the notion of alarming climate change.
And yet you're not suggesting that man isn't having some influence, and yet as soon as you say that you're not an alarmist, then there are all sorts of things equated with your view which you're not saying. In other words, you know, they're saying, well, he doesn't believe in any human influence. He doesn't even believe the CO2 is important, and that's not what you're saying.
Right. It's all a matter of degree, I suppose, that carbon dioxide is a radiatively active gas. It can't be anything else but a radiatively active gas, and so it will have some effect. What we believe, based upon the information we have, is that the responses in the climate system to that extra CO2 are not amplifying it at all, hardly at all, and so that the catastrophe out there that is being promoted is just not going to happen.
Is there a way to get the spectrum back? I mean, do we live in a binary society, to put it in mathematical terms, where you're either a 0 or you're a 1 and the 0.7s have gone away?
Well, that's a good point. It will get back to the real scientific nature of it when it is removed from the political sphere, removed from legislative actions, and I don't see that anytime soon, because our science relates directly to energy policy. Energy policy relates directly to the cost you pay for your electricity and for your gasoline. And those are real costs. And our science, as murky as it is related directly to those regulations that determine the cost.
Before the so-called ClimateGate scandal erupted. That scandal erupted last December after someone, who we don't know, hasn't been identified yet, hacked in to the files of the Climate Research Unit of East Anglia University. They're one of the groups that collects all the worldwide data on temperatures from various meteorological stations. The emails between their researchers and comparable institutions in the United States are quite revealing. They reveal what I feel is an appalling lack of scientific integrity. They conspired to discredit and to prevent the publication of papers from other scientists who disagreed with them. They also indicate that they tried to suppress data so that they didn't have to respond to requests from the Freedom of Information Acts, both in the US and the UK. When recently the BBC interviewed Phil Jones, who is head of the Climate Research Institute, they asked him about this hockey stick and how it obliterated the medieval warm period. His response was that he was still convinced that the medieval warm period was strictly a local European phenomenon. So here's the latest on the subject. Published by one of his colleagues, Ken Briffer. And this supposedly confirmed man's hockey stick. But when this was checked out by McIntyre, you see the results. Briffer used 12 trees for his data in recent years. And one particular freakish tree was what's responsible for this sharp rise. When McIntyre checked his results using 34 trees from a site nearby, they didn't show a hockey stick. Now this directly contradicts what most climatologists knew. And most knowledgeable climatologists were exceedingly skeptical of this when it first appeared, but the IPCC paid no attention to them. Most climatologists have known for years that tree rings are not particularly reliable temperature proxies. They're notoriously unreliable. They're influenced by many other factors: rainfall, sunlight, cloudiness, the presence of pests, competition from adjacent trees, soil nutrients, frost, and snow duration. When other researchers compiled data over the same period of time using 18 other different proxies that were much more reliable than tree rings, this is what they got. This is Craig Lowy, who used those 18 proxies. And as you can see, they show what most climatologists had known for decades, namely that there was a medieval warm period, a little ice age, and that today's temperatures are well below what they were in the medieval warm period. So finally, here are the comments of a fairly distinguished Australian climatologist about the infamous hockey stick that the IPCC accepted without question. And I'm quoting, quote, "What is disquieting about the hockey stick is not its original publication. As with any paper, it would sink into oblivion if found to be flawed. Rather, it was the reaction of the greenhouse industry to it, the chorus of approval, the complete lack of critical evaluation of the theory, the blind acceptance of evidence that was so flimsy. The industry embraced the theory for one reason and one reason only. It told them exactly what they wanted to hear." That sound familiar to you? Do you remember the Iraqi defector whose code name was Curveball, and all the stories he told about all the weapons of mass destruction that were in Iraq? The Bush administration accepted it. Why? Because that's just what it wanted to hear in order to justify its invasion of Iraq. And the same was true of this hockey stick. It justified the prejudices that the IPCC had and the propaganda they wanted to promulgate. John Daly, who I quoted earlier, died shortly after he wrote those words. And in one of the ClimateGate emails, his death is mentioned as a kind of fortunate occurrence. It was, and I quote, cheering news that removed one of their adversaries. Now, he knew it was phony from day one.
If you're working in a lab or in a university and you're playing around with ideas and experiments and so on, there's always an academic or scientific responsibility that you have to be able to show your work and explain your work and so on. And in many cases that's not being fulfilled. I mean, the hockey stick, where finally it was tested after how they done it was disclosed, saying, you know, we can't, this is wrong. But when you go public and say, here's the results and this is the truth, then there's a social responsibility that kicks in. And unfortunately, and in some ways, if the politician does it, that's fine, because the credibility of politicians is so low. And the public understand they're doing it for a political motive. But when you get a scientist going public with it for a political motive, bringing the credibility of science to it, but doing it for their own political agenda, then you have really crossed that line between the scientific responsibility and the social responsibility. And in fact, I'm writing an article right now about a scientist. One of his pieces of information was that the world's warmed by 1 degree Fahrenheit or 0.6 degrees Celsius in the last 130 years. Well, he's refusing to disclose how he came up with that number. And I mean, I personally think that's almost criminal. If you are, what are you hiding? If it's just numbers, what's the problem? And he actually wrote an email to Warwick Hughes, the Australian researcher, said, you know, how did you get this number? And he said, why should I share that with you? It took 25 years of my work, and all you want to do is find fault with it. That's a scary comment coming from a scientist. He's still blocking it, by the way. He's using the UK Met Office to claim that there's confidentiality. Now, the public might say, well, how is this a big deal? I mean, surely there's the raw data, and then you come up, anybody can get the raw data and match his numbers. But what the public need to know is that there are 4 major agencies producing global temperature on an annual basis. They come up with different numbers each year. And the number, I remember one year, it varied by 0.4 degrees Celsius. Well, if you're saying 0.6 in 100 years, and each year you're differing by 0.4, using the same data, well, the reason there's a difference is because you don't use the raw data. You adjust, you modify, manipulate the raw data. And of course, at what point are you doing it to get the result that you want? Well, if you're not willing to disclose how you came up with your number, the suspicion has to be, you cooked the books, fella. And I think if that number of 0.6, which is quoted everywhere, National Geographic have it on, the NOAA, the American National Oceanographic, they've on their website, Environment Canada used the number, and yet here the guy that produced it is not willing to explain how he got it. We got a serious problem on our hands, and of course what's interesting is nobody wants to come out and say you cooked the books. But what other explanation can you come up with for not disclosing that information? I mean, how could it be possibly secret or confidential? The difficulty is, and Tolstoy identified this 100 years ago, you know, that if you've made a career out of selling an idea and to your friends and to your colleagues and to the world, and then you've got to be the one that comes out and says, gee, you know what I told you, completely wrong. That's tough, very tough. And but if we're going to influence entire energy and economic programs for the world, because cap and trade, Kyoto, all of these things are based on these numbers, there is a massive, massive social responsibility. And unfortunately, there have been enough of these people that have not been willing to accept that and have crossed the line. So it isn't just that the politicians have politicized science, it's those scientists that have politicized science that are the problem.
There are numerous pieces of evidence, some of them quite rigorous, that the current models are greatly exaggerating climate sensitivity, that in reality it's very modest, and what we're dealing with is a potential effect over the next century or so of a fraction of a degree, and there is no evidence whatever that this is associated with catastrophe. You know, the issue has been promoted as something that if we don't move instantly, the world comes to an end, and it's been promoted this way for over 20 years. There is a limit to public patience on this issue. Even the environmental movement is looking for other scare topics to move on to. The question you're asking really has to do with I suppose people who have committed themselves to it, and the commitment comes in a variety of flavors. I mean, there are people who are committed to it because they will profit immensely from it. This includes investment banks looking for commissions on carbon trading, alternate energy manufacturers who are looking for subsidies, and so on. There is also a part of the public, a relatively small part, who have adopted it as a personal commitment, as a demonstration of their virtue, as almost a religious issue. It's very hard to know how you address such people. I mean, you know, it's like any other religious issue, it's no longer objective. I think the environmental movement has different considerations from other people. But for a lot of people, including the bureaucracy in government and the environmental movement, the issue is power. And, you know, it's hard to imagine a better leverage point than carbon dioxide to assume control over a society. I mean, it's essential to the production of energy. It's essential to breathing. It's a point, if you demonize it and gain control over it, you, so to speak, control everything. So that's attractive to people, and it's been openly stated for over 40 years that, you know, one should try to use this issue for a variety of purposes, ranging from north-south redistribution to energy independence to God knows what. But using models, especially models that don't test out very well, to predict long into the future beyond the time scale for which they function does not seem wise. I think in the case of climate models, it's almost like appealing to a Ouija board. But what isn't realized is the models are quite similar to each other, and their agreement on climate sensitivity within a broad range hardly proves anything. It depends on rather delicate feedbacks, and primarily on feedbacks from clouds. And even the IPCC acknowledges that we're virtually ignorant of clouds, and the models do a very bad job on them. So if you understand how the feedbacks function, you realize that statement is tantamount to the statement that the models cannot be used to predict climate.
All of us scientists are government employees, even if we're working for private universities. All research is supported by the government. So as such, we're very sensitive to what politicians say and believe. Well, that's a shortcoming. You have to figure out how to fund science in a way that there are no incentives to artificially promoting things. You know, when you hear, for instance, a scientist saying the science is settled, you know that person has stepped out of the science. So, you know, I think that registers with ordinary people. And whenever you see someone say, you know, instead of answering arguments, how could so many people agree if it weren't true? It should be a red flag. My view is one has conflated the trivial, which is that temperature is changing, climate is changing, man plays some role. There's not much disagreement with predictions of disaster that are not connected clearly to warming or to our activities or to anything else, and leaving people with the thought that if the first part is true, the second part must be true. That is certainly not the case. And then to add insult to injury, to propose policies that would have nothing to do with any of it, but involve trillions of dollars and harm to many people, is, I think, crossing the line.
Pretty compelling. And as you know, I'm a member of the advisory board of the Union of Concerned Scientists, and I find my colleagues pretty compelling, much more so than his view is a minority on a scale that's impressive. It's probably 100,000 to 1 or so, scientists versus him.
Richard,
but I don't want to get it to be a personal attack. And,
okay, Richard, are you one of the alone ones in this?
You know, on what I was just saying, I was saying textbook material. And if the textbooks are outvoiced by environmental advocacy groups like Union of Concerned Scientists by 100,000 to 1, that would be bizarre. We should close down our schools. This makes no sense, what Mr. Nye is saying. I'm simply saying his comments about the Gulf Stream are wrong. And his comments about heat transport are wrong. And that is not 100,000 to 1.
Just to clarify, I said that Larry asked me about fresh water falling on the ocean.
Yeah,
That's
and
what I said.
fresh water...
That would be the ultimate consequence.
Yeah, and all I'm saying is the thermohaline circulation is not the major driver of the Gulf Stream. The Gulf Stream is
So
not
you're saying
what
that we
keeps
shouldn't
your-
be concerned about global climate change because
Nobody is
wind
saying-
drives the Gulf Stream?
Nobody is saying
That's not enough for
anything...
me.
Well, nobody is saying anything of the sort. We are simply saying that if you wish to issue scare remarks, you should make them accurate according to the science.
So it'll be very dangerous if the world gets 2 degrees Fahrenheit warmer in, say, the next 50 years. It'll be dangerous for almost everybody. Now, do you
In what
disagree with
sense?
that?
Yes, of course I do. I mean, there is no study that suggests that 2 degrees Fahrenheit will make the world appreciably more dangerous.
I started doing just a tiny bit of research on my own, and it didn't take me any time at all to find out that, in fact, there is a raging debate about climate in the science community, that there isn't just one point of view, that in fact there are many very credentialed, experienced, sincere scientists who have some very big doubts. And I got very annoyed that I had not heard about those scientists, that I had only heard one side of the story.
Where does this 97% figure come from?
Long story short, some very, very flawed surveys of literature in the scientific literature have been used to come up with this 97%. But, you know, when you look at the methodology of those surveys, there's tons of problems. They're not reputable. But the side of the debate that is very concerned about climate change will seize on that 97% headline, and they're actually not very rigorous about looking underneath to see whether, you know, is this reputable research or not. And so, for example, we're told that the Intergovernmental Panel on Climate Change is supposed to be this body of the world's top scientists, and they all agree that climate change is a big problem and it's caused by humans and it's going to be catastrophic. Well, that's absolutely false, because those scientists who work on those reports are not polled. No one asks them. No one asks them on an individual basis, do you agree with that statement? In fact, only a few dozen people who work on one particular chapter, which is the attribution chapter of an IPCC report, get to make a decision and express a viewpoint about whether this is predominantly linked to human activity. A very small number. So, 97% of scientists have never been asked that question. So, the perception that that's the case is, it's wrong, and it doesn't take a lot of time or a lot of effort to do some very rudimentary research online and find that out. And the short form is IPCC, Intergovernmental Panel. And that's the key. This is not a panel of scientists. This is a panel of governments. It's a UN organization. The membership of the IPCC is nations. Okay, so this panel writes this report, this massive report. Around every 6 or 7 years, it comes out with a new one. This fall, in late 2013, there's going to be assessment report number 5. And sometimes those reports are called the Climate Bible, because they are supposed to be the last best word on what's happening in climate research. This panel is supposed to survey all that research and write a report, and then governments of the world take a look at that report and say, well, we have to act on climate change because the IPCC, this UN body, says it's happening and it's serious and it's our fault. So this report, so I started hearing about this report and this organization. I'm doing my research, and I got this picture in my mind of this organization because the praise was consistent across the board. Journalists thought this organization was fabulous. Scientists thought it was fabulous. And so I formed this picture in my mind of what the IPCC was. And it was of this very upstanding, meticulous professional in business attire. And, people use words like preeminent and authoritative and gold standard. This is the IPCC. And then something strange happened, because the more I actually learned about the IPCC, and because my background was investigative journalism, when someone says we do X, I don't take their word for it. I actually go and check. Do they do X? So once I started, doing some very basic fact checking, my image of the upstanding professional in business attire vanished.
We face a special problem in publication. Have you all heard about the ClimateGate emails? Yeah. The evidence is there. As soon as a paper from a skeptical group or a skeptic is published in a respected peer-reviewed journal, this does happen occasionally when we have an editor who is impartial and when he picks referees who are reasonably balanced. This peer review business depends very much on the editor. He can always pick reviewers who will say this paper is no good. Or he can pick reviewers who will say, go ahead and publish it. Okay, this happened to us. We published a paper in the International Journal of Climatology. As soon as it appeared, as soon as it was published on the web, it appeared on the internet, a task group was formed among the alarmists, and we see it in the emails that this paper has to be destroyed. This is a terrible event. So they produced a paper with 24 co-authors. 24. Can you imagine 24 co-authors? Well, it was written by one guy, and he got it published because the editor, Glenn McGregor, in Auckland, you know him, played along with it. They bullied him, and he published a paper. And now they say, well, the original paper by us is old science, or it's controversial. It's dead science.
Yeah, it's a wonderful. Control of language is brilliant from the other side, and you all know this because you've been talked into it yourself. You all talk about carbon, for example. Nothing to do with carbon. It's to do with carbon dioxide. And yet we have people up to the level of prime ministers and premiers getting up in public and talking about the carbon problem. Let's have a carbon tax. It's not a carbon tax. It's a carbon dioxide tax. You don't talk about Los Angeles water supply in terms of hydrogen. Well, Schwarzenegger might, but most of us don't. So control of language is brilliant, and this one that Fred's just given you is an example of that. That's really clever language. So they now talk about Fred's earlier paper as that's dead science. I mean, that's clever. And just consider the fact you're seeing here two random skeptical scientists, yet the event that Fred's just told you about, I have had exactly the same experience of publishing a skeptical paper, getting it through in the mainstream literature, immediately, literally overnight, an international hit team is assembled to write the destruction of that paper and make sure it becomes, in their lingo, dead science. Then, when you are offered, as you must be by an international journal, the right of reply, you write a reply to the criticism showing it's without foundation, and they refuse to publish it. That's what happens.
The billions of dollars invested in climate science means there is a huge constituency of people dependent upon those dollars. And they will want to see that carry forward. It happens in any bureaucracy.
Where I live, we have a local council global warming officer. There's a huge tail out there of people who have, in one way or another, been recruited to join this particular bandwagon.
Anybody who stands up and says, hey, wait a minute, let's look at this coolly and rationally and carefully and see actually how much merit, how much this stands up, they will be ostracized.
Scientists, accustomed to the relative civility and obscurity of academic life, suddenly find themselves publicly attacked if they dare to challenge the theory of man-made global warming, vilified by campaign groups and even within their own universities.
It's the old English saying, if you stand up in the coconut shy, they're going to throw at you. So I understand that there's going to be some of that, but it gets pretty difficult and pretty nasty and very personal. And there've been, death threats and all sorts of things. And so I'm not doing it for my health.
So Obama said last year that 2014 was the hottest year ever, but it's not true. It's not the hottest year. So if you don't believe I'm cheating you, here's some satellite data, and this is the peak in '98, and you see basically the satellite data shows the same thing. The temperature has not increased. So what is then a greenhouse effect? Well, without the atmosphere, the Earth would have been roughly 35 degrees warmer, roughly speaking. Now, from 1898 to 1998, the temperature has increased 0.8 degrees. And the CO2 concentration has increased from 295 to 367, or roughly 72 parts per million in 100 years. That's what has happened. That's the fact. I'm not making this up. Now from 1998, which is basically the hottest year, the CO2 has increased from 367 to 403, roughly 36 parts per million. That's half of the previous increase. So why hasn't the temperature increased 0.4 degrees then? I mean, if you're a physicist, for heaven's sake, and here's the experiment, and you have a theory, and the theory doesn't agree with the experiment, then you have to cut out the theory. You were wrong with the theory. See, that's half the thing. It should have been, but it isn't. So you can't believe then the people who are the alarmists said that CO2 is a terrible thing, and therefore you have to not drive and use solar cells and stuff because otherwise the world will go to pot. But it's not true. It's absolutely not true. And nobody mentioned in nature how important the CO2 is for plant growth. If you have more CO2, the plant grows faster. People use greenhouses and put CO2 in greenhouses to get a higher yield. But now, since the CO2 has increased, we get more plant and more growth faster. It's a wonderful thing.
Hello, my name is Sherwood Idso, and I am extremely pleased to accept the very first Frederick Seitz Memorial Award, which is sponsored by the Science and Environmental Policy Project. I'm sorry I'm not able to be with you in Las Vegas today, but I hope that my following few remarks may atone for my absence. First of all, I want to thank you all for coming and for your own contributions to the effort to put sound science at the center of the global debate over potential climate change and its public policy implications, which is the great cause to which I have devoted the past 3.5 decades of my professional life. My involvement in the study of the climatic effects of atmospheric CO2 enrichment commenced some 13 years after I had begun my career at the U.S. Water Conservation Laboratory in Phoenix, Arizona. It started with the publication in a prominent science journal of a paper I had written entitled "The Climatological Significance of a Doubling of Earth's Atmospheric Carbon Dioxide Concentration," wherein I provided real-world evidence suggesting that the true degree of warming likely to be caused by a doubling of the air's CO2 content would be a full order of magnitude less than that which was being predicted by the climate alarmists of that day. And I subsequently wrote paper after paper exploring various aspects of the subject, based on the results of a number of what I called natural experiments, where I employed different sets of temperature data driven by different phenomena in different parts of the world, which all led to essentially the same conclusion. Also, on my own time, I wrote and self-published 2 books on the subject, Carbon Dioxide, Friend or Foe in 1982, and Carbon Dioxide and Global Change, Earth in Transition in 1989, neither of which endeared me to the scientific establishment. In fact, I subsequently learned from 2 people who were present at a special meeting of the U.S. National Academy of Sciences that many of that group wanted to censure me for what I had written, but that a couple of cooler heads ultimately prevailed and convinced the group not to do so. And so I continued my study of the sensitive subject, but not so sensitively, actually expanding its scope to include the biological effects of atmospheric CO2 enrichment, nearly all of which have been proven to be positive. As but one example, in the longest such study ever conducted, my colleagues and I grew some initially very small sour orange tree seedlings out of doors in clear plastic wall open-top chambers for 17 years. Finding along the way and at the study's conclusion, when the trees towered above us, that the 70% increase in the CO2 content of the CO2-enriched chambers increased the woody biomass production of the trees by essentially the same percentage, while the cumulative amount of fruit produced over the duration of the experiment was increased by some 85% due to the elevated CO2. And as a modest nutrition bonus, the vitamin C content of the juice of the fruit rose by 7%.
Welcome to Conversations That Matter. Mike, today we're having another of our conversations with an eminent scientist from Princeton University. Let's talk a little bit about who our guest is today.
Today we'll hear from Freeman Dyson. He's a 91-year-old mathematical physicist, one of the most renowned scientists in the United States, been around for 6 decades.
He's an extraordinary mind. Talking to one of our previous guests who went, you're talking to who? Like, to say that he has a big brain would be an understatement.
That's right, and this is someone who actually works in the same building at Princeton that Einstein worked in. and interestingly enough, not only works in that building, but he was actually there when Einstein was there.
I know, it's extraordinary. You go into the building, there's this bust of Albert Einstein, and the address is 1 Einstein Drive, and it dawns on you that this is a place where some rather extraordinary thinking happens.
Extraordinary, and in his own words, subversive science.
Contrarian.
Contrarian, yeah. Freeman Dyson believes we ought to be using science as a way to upend the apple cart, and particularly teach young people that science can be an act of rebellion, positive rebellion, you know, to push against poverty.
There's many people who are on the climate change side of the equation who are advocating that we're in trouble, and they say that science supports that. They're not going to be so happy with the conversation with Freeman Dyson.
Well, Freeman Dyson is probably someone that comes out on more of the neutral side in terms of climate change. He obviously acknowledges that there's rising carbon in the environment.
And that the temperature has gone up.
The temperature has gone up. But I think his approach is to say we don't know enough. And you know, we need to focus on things in the world that we know enough about to change.
You're right, not knowing enough. He says, well, I know the guy who designed the first computer model that all other models are based on. Like, he knows the guy, and he knows that the model can't mirror what is in climate. And this is his point. And so he says, yes, we've had this effect, but it's the predictive model that is difficult for him to embrace.
That's right, and which is what makes his voice on this issue, particularly as somewhat of a contrarian, even that much more important and pivotal, really, in the entire debate.
Oh, there are people who are not going to be happy with what Mr. Dyson has to say, but it's a conversation that we believe was worth having. Let's go to that now. Man-made climate change, where are we at from your perspective? Is it incontrovertible science, or are we being led down a path that you are suspicious of?
Well, first of all, there is man-made climate change. I mean, it's a question how much, and is it good or bad? And there are all sorts of questions. The fact that it exists is not a question. Certainly there is some effect of humans on climate, and we have to try to find out what it is. All I would say is, first of all, we don't understand the details. It's probably much less than is generally claimed. And the most important thing is that there are huge non-climate effects of carbon dioxide which are overwhelmingly favorable, which are not taken into account. To me, that's the main issue, that the Earth is actually growing greener. This has been actually measured from satellites. The whole Earth is growing greener as a result of carbon dioxide in the atmosphere. So it's increasing agricultural yields, it's increasing the forests, it's increasing all kinds of growth in the biological world. And that's more important and more certain than the effects on climate.
Well, this is where you started your research, isn't it? In the effects of CO2 on vegetation.
Yes.
And over the years, what have you found?
Well, it's increasing just more or less as we expected. I started working on this 37 years ago, and at a time when there were, we thought the effects were maybe about 10%, and now it's probably more like 25% after 35 years. It's essentially what we expected. Carbon dioxide in the atmosphere has gone up by 40% in that time, or something like that.
Yeah, up to about 400 parts per million at the moment. Just shy of that, I think.
Yes, about half of that is gone into raising vegetation. So vegetation has increased on the average by around 20%. And that's observed. And of course it's extremely important. It actually is enormously beneficial both to food production and also to the biodiversity, preservation of species and everything else that's good. So the remarkable thing is that these effects, which have nothing to do with climate, effects of carbon dioxide in the atmosphere, so much easier to measure than the effects on climate, and so much more certain.
Well, I know that in a greenhouse where there is, industrial growing of plants for food production, the carbon dioxide parts per million is up around 1,200 parts per million. We know that it works in an actual greenhouse, but there was a considerable amount of concern as to whether or not that would actually translate into the atmosphere globally. And you're saying that the evidence is in that the benefit exists in the world at large as well.
Yes, on the average. I mean, of course, it's not true everywhere, and you can find cases where it doesn't work and cases where it does work. If you look at the details, it depends on what other nutrients are available. Of course, if the growth of plants is limited by not having enough nitrogen, then giving it more carbon won't help. And so most of the time there is enough nitrogen, and giving it more carbon does help. So it's understandable that the effects vary from place to place.